So when you look back over your career, which has spanned several decades, obviously, you've accomplished a great deal. Are there some things that you feel is kind of astounding that you managed to, some areas where you think it's astounding that perhaps we've advanced as much as we have, and other areas where it's perhaps disappointing that we haven't made as many changes that we would have liked to have done?
I think that's a very useful question because it's interesting to go back and look at papers and documents that were written, say, in the 80s. I mean, I got my PhD in '76, but sort of look back and see the progress that we've made. So in optimization, at various points, people have said, well, for nonlinear problems, you can solve problems with hundreds of variables. Of course, that's a very imprecise statement. They never say what kind of problems or whatever. Today, we had a talk where the person was talking about hundreds of thousands or millions of variables. That's an amazing change. It's an amazing change in capability. Mm-hmm. And it's not all due to computer hardware. I think sometimes people think, oh, machines are faster, machines are bigger. But it's smarter and better algorithms, which is the area that you and I work in, right? Not making faster machines. We try to take advantage of them, but we don't make them run faster. And to me, that's astonishing. And the great part of it is, I think, there are still interesting problems that don't have many variables. In this non-derivative optimization area, something that's been fascinating to me is cancer chemotherapy. What's the optimal set of drugs you should take with your kind of cancer for your own needs? That's not very many variables. It's highly nonlinear. You don't have derivatives. How can you do that in an intelligent way? Instead of the doctor saying, well, let's double this one and cut this one in half. Can we be smarter than that? But you have to be really careful. You can't just try it on a lot of patients as you would with a computer simulation. And then there are problems with enormous numbers of variables that are really hard that people want to solve.
And how about if we ask the same question, but not in relation to advances in research, but in relation to advances in society, say the role of women, minorities, other whatever else you might want to mention?
There's no doubt that the situation for women is much better than when I started my career. The kinds of pretty obnoxious comments that were always made to me, you know, like, you only got to do this because you were a woman, or as someone said to me once at Sylvania, do you know what a cosine is? I mean, you know, that kind of comment people don't tend to make now. Now, whether they secretly think it, I don't know. So I think women have advanced a lot, but there's a long way to go. And talking to women students at Currant, I can tell that they're not always getting the encouragement to do things that the male students are. Or they're put off by aspects of the profession, math or computer science, that I don't fully understand. I was taught programming in the days when it was like boot camp. You know, you have to program this. It doesn't have any real-world applications. I love that. I thought it was great. But some women don't like that. So can we do better for them? And I think with math, we don't always do a good job of making clear what useful things math can do. I don't know how many applied math courses start off by saying, here's a real-world application and here's how this got solved, and isn't that exciting? I think personally that would be good, but there are people who feel that's dumbing down and you should, you know, stay rigorous and theoretical. For minorities, I think it's much harder, and there's still a lot of work to be done. And I work closely with some people in the minority community, and I think an issue there is they have more options. You know, a lot of places would really like to encourage minorities to go into science and engineering. That doesn't mean math and computer science. So I think we just have to do a better job there by making it attractive. I mean, there's this sort of funny thing. So sometimes people will ask me about being a woman, and I'll say, well, you know, it wasn't so nice when people would make these pretty nasty comments to me about being a woman and, you know, how you're inferior. And they say, well, that should challenge you. That should make you want to succeed. And it's true that if someone says to you, you're no good, you think, yes, I am. But not everybody reacts that way. Some people say, you say I'm no good, I don't want to be around you. You know, I don't want to be here in this group. So it's not the case that everybody reacts well to criticism. there was a department head at Bell Labs, not in my center, thank God, who used to give the best people bad write-ups. And we would say, why are you doing that? I mean, this guy was a jerk and he didn't stay as a department head very long. And he said, well, I want to challenge them. I want to spur them to do better. And the rest of us said, but it's wrong, it's unfair. Why are you doing this? He said, well, that's the way to get them to perform. I really found that hard to credit.